Hello everyone, welcome to this session on air pollution and management. This topic is something not unfamiliar for you. We have been discussing this topic on when we were talking about planetary boundaries, global warming, and also the history of environmental problems. This was an important topic for us because after the Industrial Revolution, there were a lot of problems related to air quality, and this was because of the burning of fossil fuels. There has been several episodes that we will also discuss. One of the most important ones are the ones that occur in London and that have killed thousands of people on different events. Currently, there has been also respiratory problems associated with air pollution still. We have cases in Sydney, and we also have cases in Europe and all over the world because of this situation. As you can see globally, air pollution is highly concentrated where human settlements are located, right? So you can see that cities that are highly populated or regions that are highly populated are the ones who have the most significant impacts in terms of air quality. So air pollution has several impacts. It causes environmental issues such as eutrophication, acidification, ozone layer depletion, damages to crops and trees, and at a global scale, we have discussed global warming. Air pollution also causes significant issues with human health, respiratory problems, etc. But what is interesting also to mention is that the costs associated with air pollution are very large and is estimated only in Australia in billions of dollars. So air pollution is a public health concern on the micro, meso, and macro scales. Indoor air pollution results from products used in construction materials, the inadequacy of general ventilation, or geophysical factors that may result in exposure to naturally occurring radioactive materials. Industrial and mobile sources contribute to mesoscale air pollution that contaminates the ambient air that surrounds us outdoors. Macroscale or global effects include transport of ambient air pollutants over large distances. The examples that we have mentioned before of macro-scale effects include acid rain and ozone pollution. And the global effects of air pollution, you are already very aware of them, is like the depletion of the ozone layer and the global warming, which are included also on the planetary boundaries. So talking about these major pollution episodes, we have here a list of episodes that have occurred in London, in Europe, in Belgium, and also in the USA. We have the number of deaths that are being attributed to these air pollution problems, and also the period of time and what were the characteristics. So after the last two episodes of this list that I'm mentioning, governments of the USA and UK introduced pollution control measures, which made a significant difference on air quality. So this happens only after 1952. And this was mostly due to the removal of polluting industries from the urban airsheet and the introduction of anti-pollution devices in cars and industrial stacks. So here we can see the length of the episodes that occur on the 1952 fog that occurred in London, and we can see the concentration, the number of deaths, and the smoke, the concentration of smoke in micrograms per cubic meter. So you can see that there is a direct correlation between the number of deaths, the number of smoke, and also the concentration of sulfur dioxide. We have to mention here that although we focus here on anthropogenic pollutants, there are natural sources too. These include forest fires, volcanic emissions, and on the other hand, the anthropogenic ones that we discuss are the ones that can be divided into mobile or stationary. And we also focus on focus points and diffuse points. So also we're going to have another distinction between pollutants. The ones that are directly emitted from a source, these are called primary pollutants. And we also have the ones that result from subsequent atmospheric reactions. These are called secondary pollutants. So the environmental protection agencies all over the world and also the World Health Organization have identified key urban air pollutants. These include sulfur dioxides, nitrous oxides, particulate matter, carbon monoxide, lead, ozone, volatile organic compounds. There has been an identification of the major sources and also the health effects and the environmental effects. We're going to discuss this more in detail in the next session. So to warm up a little bit, we're going to start doing a basic mass balance example. We're going to consider this event on 1952 in London, where sulfur dioxide was produced from burning coal. During this event, there was an inversion that we're going to describe later, so the inversion formed a lid at about 150 meters height and covered an area of 1,200 square kilometers. Approximately 25,000 tons of coal were burned per week, with an average sulfur content of 4%. So with these values, we could estimate the concentration of sulfur dioxide that we had at the end of the 2 weeks. So how can we do this? How can we estimate this concentration? We can develop a simple model based on what goes into the airshed volume during these 2 weeks and could not escape. So this is the volume where the sulfur dioxide was trapped. So after calculations, we know that the concentration that we had after 2 weeks was approximately 22,000 micrograms per cubic meter. We know now that the US standard for daily average exposure of sulfur dioxide is 365 micrograms per cubic meter. And we also know now that the actual recorded peak was 2,000 micrograms per cubic meter. So how come this concentration was more than 10 times lower than the concentration that we found with our calculations? Well, we will see later that there are some other processes going on that can transform the sulfur dioxide into other sulfur forms, and that also sulfur can be retained by vegetation and can have some other interactions in the atmosphere. So after these major events all over the world, and also in Australia, after the growing of the population in certain areas and concerns about air quality, we have created in Australia, of course, Australian monitoring stations. As you can see, is something to be noticed is that these monitoring stations are in the major cities because that's where the pollution is being released mainly, right? So these are mostly close to capital cities and also where larger populations exist. So the same pollutants that we discussed before are the ones that are considered on the Avian Air Quality National Environmental Protection Measure. In these guidelines from the Department of Sustainability, we know that what is the standard concentration, the average in time, and the goal, which is what is the maximum concentration in a period of time that can be that are a limit for optimal air quality conditions. So in Australia, air pollution is assessed based on an index. This is called the Air Quality Index, and it's been calculated based on the pollutant concentration and the standard. This standard is the one that we just mentioned on the table of the provided by the Air Quality National Environmental Protection Measure. So an index value less than 100 means the pollutant has not exceeded the standard, and a value equal to or greater than 100 means the pollutant has exceeded the relevant air quality standard. So based on the air quality index, how is the air quality in an area in which the average atmospheric particulate matter PM10 concentration, as measured over a one-day period, is 53 micrograms per cubic meter? To answer this question, we need to go back and look at the table of the pollutant standards, and then we identify or we allocate the particulate matter PM10, which standard is 50 micrograms per cubic meter for an average time of one day. Then we go back to the air quality assessment or the air quality index formula, and then we estimate the AQI, and then we can come up with an answer. In this case, the answer is that the air quality is poor. So the air quality is unhealthy for sensitive groups.